Hello everyone, now we are going to discuss the next topic, that is logarithmic decrement. My dear students, we have studied undertimed system where we have got the relations, complementary functions as well as we have drawn the graph of the amplitude with respect to time, because the amplitude is a function of time and it is exponential decreasing function. Okay, so we got the, when we draw the graph we have seen that there are certain values. Let me draw the graph roughly so that we will be able to remind it. So the graph was like that, and this is the graph of complementary functions, and it becomes zero after certain times because this is the complementary functions. Okay, so we have seen that there are, this is TD and this is 2TD, like that, and this is the x naught, and this is the graph of amplitude, that is x is equal x that is the amplitude, that means x multiply e to the power minus zeta omega n into t. Okay, where t is equal to td, 2td, like that, and that is minus x e to the power minus zeta omega n into t. Now at t barabar 0, what would be the value of x naught? Because let me write down the equations, that is x is equal to capital X e to the power minus zeta omega n into td, omega n into t, multiply sine omega d, because this is the time system, plus phi, where phi and x, capital X is constant. At t barabar 0, sin omega t plus phi would become 0. That means we'll get x is equal to, that means if this is 0, that means that would be sin phi. That means you'll get x, capital X sin phi. This is x. Similarly, when you put the t is equal to, this is at t barabar 0. Again, when you put t is equal to td, the value of x1, that would be x e to the power minus zeta omega n td sin phi. Similarly, you can calculate all these values. Now, the certain things which we need to understand, that first we need to calculate decrement ratios. What is decrement ratio? See here, you can see the graph is going to be decreases in the further forward directions. Okay, as time goes on. So that means the ratio is going to be decrement ratios. This is decrement ratio. Decrement ratio. The amplitude is going to be decreases with time. So the decrement ratio would be x naught upon x1, which is also equal to x1 upon x2. We will see how these are equal to each other. We will see. Similarly, x2 upon x3, like that, and so on, because the value of this ratio is equal to e to the power zeta omega n multiplied td, which is constant. That's why it is known as decrement ratio. This is zeta omega n into td. Okay, so this is constant. So that's why this is x naught upon x1 is equal to x1 upon x2 is equal to x3 upon x3, and so on. Okay, now we are going to calculate the logarithmic decrement. This is our topic. What is logarithmic decrement? Basically, this is whole term which is e to the power zeta omega n into td. So we have representing the new term, that is logarithmic decrement, denoted as del, that is equal to logarithmic decrement means ln e to the power zeta, this complete term. Okay, e to the power zeta omega n into td. That is our logarithmic decrement. So when you solve this, you will get the base is e. That's why it will be del is equal to zeta omega n into td. Okay, so you can just replace the value of td. So it would be zeta omega n 2 pi upon omega d? Yes or no? We know that Td is equal to 2 pi upon omega d. And we know that omega d is equal to what? Omega d is equal to under root of 1 minus zeta square multiply omega n. That is omega d. Omega d means under root of 1 minus zeta square multiply omega n. So this will be cancelled out. So finally the logarithmic decrement value comes out to be del is equal to 2 pi zeta upon under root of 1 minus zeta square. So now you can find out the logarithmic decrement just by putting the value of damping factor or the damping ratio. Zeta denoting the damping ratio here. This is damping ratio or damping factor. Okay. So this was the logarithmic decrement. Now one more thing I am going to discuss here. This is a small thing that however I have not discussed it before. So let me discuss it here. That is critical damped coefficient. This is a small topic. Critical damped coefficient. This is important from numerical point of view. Critical damped coefficient is denoted as CC. CC. Okay. Critically damped coefficient CC. So now, what is the CC basically for the critical? Critical, when the term used critical, we know that for critical damped system, the zeta is equal to 1. We all know that. So in generally, we know that C by M is equal to 2 zeta omega n. Okay, we know that this is the general formula. So, but if you calculate for critical damped coefficient, that will be CC upon M. That's equal to 2 zeta omega n, where the value of zeta would be equal to 1. That means it would be equal to 1. So when you take the ratio, you will get the value of C upon CC. You will get zeta. When you find out the ratio of these two equations, this is first equation, this is second equation, we will get the ratio of this. So you can call it as the actual damping coefficient. Actual damping coefficient. Actual damping coefficient and upon critical damping coefficient. Critical damping coefficient. So you are able to find out the things. Whatever be the examiners ask you, you can calculate. Now, this is the important things which you must understand. Sometimes it will not give you the value of C, that means the actual damping coefficient, but they will give you the critical damping coefficient. So you just have to apply this formula. So these are the numerical questions that can ask on these types of topics. So you must understand this. You must learn these values directly, and if you are not able to understand properly, you just have to use this in questions. Do a lot of questions, practice questions. So that's why you will be able to understand how the questions going to be designed. Okay. So thank you.